Okay, so I'm Christophe Chaudier, and I will talk about our library, Open eVision, running at the edge. Okay, so my agenda will be that I will start briefly with a presentation of Euresys and Open eVision. Then I will explain why we think that Open eVision is very edge compatible. I will go step by step to what we think is a good development procedure for Open eVision on a specific smart camera, the Alex smart camera. Then I will show you some use cases running on that device, and I will conclude. So first, a word about Euresys. Euresys is a Belgian company, so we are in Liège, center of Europe, but we have also a number of sister company in the world, especially in Asia, where most of our market is. And Euresys is designing and producing components for machine vision application. So one of the product range is the frame grabbers. So we are selling co-express and camera frame grabbers. But we also sell IP core for FPGA. So that's GigaVision, co-express, USB Vision IP that you can integrate in your own design, your own camera or vision system. But today I will talk about Open eVision. Open eVision is an image processing and analysis software tools. So it's a set of software library that you can use in your own application to perform machine vision tasks. So what is it about? Open eVision is, as I said, a set of 20 different libraries covering very different topics useful for machine vision application. The general purpose libraries, that's Easy Image and Easy Color, are really kind of pre-processing the images. So doing some filtering, geometric transformation, but also some more advanced stuff like high dynamic range combination or a very powerful image stitching function. We have also a set of matching and measurements libraries. Typically, it's a conventional pattern matching, but also very efficient subpixel measurements library, and also object segmentation libraries. On the code reading and text reading side, we have a full range of code reading, QR code, data matrices, barcode, but also text reading libraries. And the latest addition is the Easy Deep OCR libraries for character recognition using deep learning. And I will talk more later. On the deep learning group, we have everything you need to do some classification, segmentation, and localization of object in image. And these libraries use conventional, not conventional, neural network to perform the inference. And we also offer tools for training. We have a range of 3D libraries that process 3D container like point clouds, meshes, depth maps, Z maps. So you can do some filtering, decimation, transformation, but also some more advanced function on 3D data like object segmentation or alignment between a CAD model and acquired point cloud. And last, we recently add what we call an applicative processing library, which is called Easy Spot Detector. It's a library dedicated to surface inspection that's mixed on a single package, conventional approach for segmentation and deep learning for classification of the defects. Okay, so that's for Open eVision, the libraries itself. But why do we think that Open eVision is good for edge processing? because Open eVision run on a broad range of device. So it's on Windows and Linux operating systems, on Intel CPU, but also on ARM CPU. And you know that ARM CPU is well used on the embedded platform. You can access and use Open eVision from C++, Python, and C# or other net framework languages. And we make a good use of multi-core and GPU. And more especially, we are getting good inference speed using Intel OpenVINO and NVIDIA TensorRT libraries that are specifically made to speed up the deep learning libraries. So typically, you can use Open eVision on a very broad range of devices, ranging from everything based on NVIDIA Jetson devices. We have a lot of different cameras running on that kind of module. I see here a Bomber camera, for example. You can also run Open eVision on low-cost devices like Raspberry Pi device. Could be interesting to make a fairly cost-effective solution. And of course, Open eVision is running fine on our embedded industrial computer with our GPU. So today I would like to specifically talk about Open eVision on Alex. And what is Alex? Alex is a new smart cameras from Allied Vision. So you have different kind of sensor. There is 2 different sensor today on Alex, 5 and 12 megapixel sensor. And that smart camera include the latest Jetson module from NVIDIA, the Orin NX processor, which give you a fairly good amount of power for image processing. There is a full range of digital IOs, so input, output, lighting control, serial communication, and everything in industrial housing, IP67, and industrial connector. But there is more, and that's why I think it's really interesting, is that Alex is ready to run Open eVision out of the box, because Open eVision 25.6 is pre-installed on Alex. So you get the libraries already installed on Alex. And there is a trial license that are also installed on the Alex smart device. So you get a full month of free licenses. There is more than 60 different sample programs provided using different framework and languages. And as I already said, Open eVision really takes advantage of the Alex multi-ARM CPU and GPU platform. So typically, how do we develop an application, vision application using Open eVision on Alex smart camera? So first, probably at the first steps, you will like to capture some picture of the Alex camera, and that will use after to prototype and test your processing pipeline. So you can take pictures on Alex using the Viewer application from Allied Vision. So it's something that is provided out of the box also. So you can set up your camera and lens and everything, and then capture some picture of your subject. Then you can use the new Open eVision Studio, which is free applications that allow you to prototype, test, demonstrate processing pipeline with Open eVision. And that application is really easy to use, and you can use many of the libraries of Open eVision and build processing pipeline. So you are not testing individual tools, but really the complete processing pipelines using the image you just capture on Alex. This application is free, so you can download it freely on Open eVision website. What's interesting with this application, it's not really dedicated to conventional only or 3D only or deep learning tools only. It's really a way to mix them. So to build complex processing pipeline, for example, using conventional pattern matching to find the object or align the object, then use deep learning on selected area or a 3D and then back to 3D. It's all possible with Open eVision Studio because you have the whole Open eVision tools inside the application. If needed, you can use Deep Learning Studio, which is another application which is also free to train an AI model. So it could be for classification, segmentation, or localization. So you can annotate your data sets, configure your training, train a model, check the results, are the performance, are the accuracy good enough? And if you're okay with the results, export the final model and use it in Open eVision Studio. What's really good with Open eVision Studio is that it dynamically generate the codes that exactly reflect the processing pipeline you design. So you can use that feature to learn about the API. It's very easy to understand how the tools and parameters are connected to the code. And you can generate the code in 3 different languages, C++, C#, and Python. So after you design your processing pipeline in Open eVision Studio and test it with the picture, and you get good results, then you can use that code in the embedded application that's run on Alex. So a typical application in its simplest form is probably composed of 3 different parts. One part to acquire the images. And so on Alex, it will be using the Vimba-X SDK from Allied Vision. Then pass that image to the image processing pipeline built with Open eVision. So here it's exactly and only the code you get from Open eVision Studio. And the third part is probably to code the decision. So check the dimension or check the results of the defect detection. So you have to put your decision code at the end. We provide with Alex a set of samples to demonstrate and help you to build that kind of application. On Alex, of course, you can use C++ or Python application using the same principles. After expiration of the trial licenses you have on the camera, and to run the application for unlimited time, you have to order license from Euresys and activate the licenses on the Alex camera. What's good with Open eVision is that you only have to buy feature license that are required for your application. So if your application just use a subset of Open eVision, here, for example, only three libraries, Easy Image, Easy Gauge, or Easy Find, you just have to buy these 3 license and activate perpetually on the Alex camera. So now some examples of application running on Alex with Open eVision. So here you can see live acquisition of code reader, a very simple code reader application. It's used the Easy Matrix Code license, and it's configured to detect only one data matrix in the picture. The results are compressed and streamed over HTTP and display on my laptop as a page on the web browser. It's running at around 32 frames per second and processing a little bit more than 1 megapixel image. Of course, Open eVision is supporting more than just data matrices. So you can read a lot of different codes with Open eVision, QR code, barcode, PDF 417 and other codes. And you have a very broad range of code reading function to read everything you need in real time on Alex. Another possible application for Open eVision on Alex is to use the latest deep learning-based optical character recognition library, which is called EasyDeep OCR. EasyDeep OCR is very convenient because with a single call to the API, you can read all the text in the picture. So it will read text in whatever the direction, the size of the font. Without any further configuration, with 2 lines of code. So you read all the text you see on the right, and it runs approximately at 400 milliseconds on Alex. It can take, of course, advantage of the GPU and use the EasyDeep OCR license. So I put at the bottom of the slide here the 2 lines of code that is required to read all the text in the picture. But most of the time, you don't need to read all the text in a sticker like that. Maybe you only would like to focus on the part number. And there is, of course, different way to focus on that. You can just define the region of interest and just read the text in that area. It will be a lot faster then. Or you can use a very interesting function of deep OCR is specifying a topology. A topology defined with like a regular expression, what kind of text you are interested in. So here we are searching, for example, for texts that are only composed of 10 digits, and it will only return that text, even if it's not at a fixed position on the image. Last example, it's object counting using deep learning. Here it's an example of reading, of detecting a small capacitor in the image. It's running approximately at 20 frames per second on Alex. And in that example, it detects up to, I think, 90 objects, 90 capacitors. And for each capacitor, you have the probability. Of course, it takes advantages of the Alex GPU. And how to develop that kind of application? As I already said, we have a helper here, helper application, which is called Deep Learning Studio, which is free, and it allows to annotate the picture and train a model, and then you have to push the model, the trained model, on Alex to get that kind of results. So to summarize my presentation, Open eVision is a set of machine vision libraries that we think are really well suited for edge processing. It covers really a broad range of machine vision function, conventional, but also 3D and deep learning vision tools. And you can combine them to make a powerful application. Using the Free Studio application, so Open eVision Studio and Deep Learning Studio, you can easily prototype and test your processing pipeline. Open eVision is pre-installed on Alex camera. So it's a really good platform to get started with Open eVision. So we think that's that combination of Open eVision SDK and Allied Vision Alex is a good way to develop cost-effective solution for vision-based inspection project, because you don't need no more PC or external device. Everything is running on the Alex smart camera. So thank you for your attention.
So thank you for the presentation. And now it's the time for the questions. You can use the chat or the Q&A section. First question, the trained model is already optimized for inference on Alex, or is it needed an additional step in the pipeline?
So Yes, no, the train run directly on Alex. So after the training, you can export the train model to Alex and it will run as is on Alex without any further optimization. It will benefit from the GPU, of course, using TensorRT and everything. So no, there is no extra step here.
Is pre-training possible?
Yeah. Yes, so our model, our classification model are pre-trained. So that means that we pre-train on a set of data, a huge set of data that are closely related to the kind of industrial inspection, typically industrial inspection. So yes, pre-train is available on deep learning for some libraries. So it's available for the classification only for now, and for segmentation and localization is not pre-trained. So you have to train for a longer time to get the best results.
Okay. Can the text code reading and AI inference be used in the same application?
So sorry, I missed the end of your question.
Can the text or code reading and AI inference be used in the same application?
Yeah. You can use all the function in the same application. Application will share the CPU or the GPU. You can combine them, so you can use, I don't know, deep OCR to detect text, and based on the text position, do some measurements on another part of the image, and then maybe do a code reading also in parallel or in sequence. Yes, you can combine different library in the same application.
Thanks. I think we have time for one question. Can an embedded library be updated?
Yes, you can. So the Alex camera is pre-installed with one version of Open eVision 25.6, but if you want to install a new version of Open eVision, you can deploy it like you do on any computer. So it's not Alex specific Open eVision library, it's the regular Open eVision library, so you can deploy newer version of the SDK on the platform, no problem.
Christoph, thank you very much. There's a question for Christoph. Maybe he can open his camera. Is it better to run Open eVision Studio and Deep Learning Studio on Alex, or is it better to use it on the developer PC? How powerful is Alex?
Yeah. Good question. So both applications run on Alex and run on PC, of course. For Deep Learning Studio, for training, we recommend to use a decent GPU. So probably you will get faster training running Deep Learning Studio on your development PC, which with a good powerful GPU. Open eVision Studio could run really on both platforms. So sometimes it would be convenient to run on Alex because you get access to the picture directly and you get the precise timing on Alex. So it's a good indication of how fast we'll run the processing pipeline. But if it's more convenient for you, you can run Open eVision Studio on your host PC and then save the project or copy paste the code on the Alex platform. So both are possible. I think that's usually you will do that all day step more on your development PC because it could be more powerful and easier. But clearly it's possible to run on both sides.
Thanks.